everyone, you're welcome to solve this nice algebra problem, which is 3 to the power of x plus 9 to the power of x plus 27 to the power of x. This is equal to 39. What is the value of x given that x is a member of real numbers? So let's provide a solution from here. This is 3 to the power of x, then plus 9 to the power of x can be expressed as 3 to the power of 2 raised to the power of x, then plus 27 to the power of x. We can express this as 3 to the power of 3 raised to the power of x. This is equal to 39. The next step is that 3 to the power of 2 raised to the power of x and 3 to the power of 3 to the power of x. This is in the form of a to the power of n raised to the power of m, which we can express as a to the power of n multiplied by m. Now, in this case, we can also express this as a to the power of m raised to the power of n. Now, we have 3 to the power of x plus 3 to the power of x raised to the power of 2, then plus 3 to the power of x, then raised to the power of 3. This is equal to 39. The next step is that we can let 3 to the power of x be equal to u. Now let's substitute 3 to the power of x with u so that we have u plus u squared plus u to the power of 3. This is equal to 39. So we can write this as u to the power of 3 plus u squared plus u. Let's take 39 on the left hand side, so minus 39. This is equal to 0. Now, this is u to the power of 3 plus u to the power of 2 plus u minus 39. We can express 39 as minus 27 subtract 9 minus 3. This is equal to 0. Now, this is u to the power of 3 plus u to the power of 2 plus u minus 27, which is 3 to the power of 3, minus 9, which is 3 to the power of 2, then subtract 3. This is equal to 0. We have u to the power of 3 and 3 to the power of 3. So this is u to the power of 3 minus 3 to the power of 3, then plus u squared minus 3 squared, then plus u minus 3. This is equal to 0. Now, the first part here, this is the difference of two cubes expressed as a to the power of 3 minus b to the power of 3, which we can express as a minus b. Then we have a squared plus ab plus b squared. The second part here, this is the difference of two squares that we can express as a squared minus b squared. That is a plus b, a minus b. So let's apply these two identities. Now this implies that u to the power of 3 minus 3 to the power of 3. This is the same thing as u minus 3. Then here we have u squared plus 3u, then plus 3 squared, which is equal to 9. Let's call this equation 1. And then we have u squared minus 3 squared. We can express this as u plus 3, then u minus 3. Let's call this equation 2. So we can write this as u minus 3, u squared plus 3u plus 9, then plus u plus 3, then we have u minus 3, then we have plus u minus 3. So we have u minus 3. This is equal to 0. So we have that u minus 3 is common here. So we can factor out u minus 3. Into the parentheses, we'll have u squared plus 3u plus 9, then plus u plus 3, then plus 1, cross the parentheses, this is equal to 0. So we have u minus 3. Here we have u squared, 3u plus u, this is plus 4u, then plus 9 plus 3, this is 12, plus 1, this is 13. This is equal to 0. Now we have two parts here. We have u minus 3, this is equal to 0. And we have the second part here, which is a quadratic equation, u squared plus 4u plus 13, this is equal to 0. From the first part here, we have that u is equal to 3. And the second part here is a quadratic equation of the form a u squared plus b u plus c, this is equal to 0. From this quadratic equation, we have that a is equal to 1, b is equal to 4, and that c is equal to 13. So we can assess the nature of the root of this quadratic equation by determining the discriminant value, which is b squared minus 4ac. So here we'll have 4 squared minus 4 times a, which is 1, times c, which is 13. Now we have 4 squared, this is 16, minus 13 times 4, this is equal to 52. So 16 minus 52, this is equal to minus 36, which is less than 0. And this implies that from here, we have two complex roots. We have two complex roots. And this means that there will be no real solution from this quadratic equation. And this violates the condition that x, remember x is a member of real numbers. So this quadratic equation part is rejected. So let's reject this quadratic equation. Now let's focus on u, which is equal to 3. If you recall, we are saying that let 3 to the power of x be equal to u. Now we are saying that let 3 to the power of x be equal to u. So this means that 3 to the power of x, this is equal to u, which is equal to 3. 3 is raised to the power of 1, and that means that the bases are common here. That is a to the power of n. This is equal to a to the power of m. Have that the bases are common here. That is a to the power of n. This is equal to a to the power of m. Now this means that exponent n is equal to m. So from what we have here, then x is equal to 1. We have the value of x equal to 1. Now let's verify that this value of x satisfies the equation. If you recall, we entered 3 to the power of x plus 9 to the power of x plus 27 to the power of x. This should give us a value of 39. So this is 3 to the power of x, which is 1, plus 9 to the power of 1, plus 27 to the power of 1. This is supposed to give us a value of 39. Now, 3 to the power of 1, this is 3, plus 9 to the power of 1, this is 9, plus 27 to the power of 1, this is 27. This is supposed to give us a value of 39. So we have 9 plus 3, this is 12, plus 27. This is equal to 39, which is equal to 39. So the left add side is equal to the right add side. And this affirms that the value of x, which is equal to 1, satisfies the equation. So kindly follow the steps, like this video, and kindly subscribe. See you in the next video. Bye bye for now.